Okay.
Okay.
Um, I'm Harry Ricker. It's Sunday, August the 24th, and it's cool here. Summer has lost its grip. The hurricane passed us by. Gosh, that thing was 1,000 miles in diameter. Wow. Did some damage in North Carolina, but we escaped here in Newport News without any problems. Okay, I'm going to talk today about fixing the mistakes in Einstein's theory. And I've talked about that before, but I'm going to talk about paradoxes today. And paradoxes are kind of examples. They like to talk about, there are really only apparent paradoxes, they don't really exist. And so they sort of try to treat them as mathematics examples. This is how you solve problems. This is how we do problem solving, like in textbooks where you have exercises. And they kind of treat it like these are exercises and solving problems. They don't really treat them as if there's actually any kind of problem or contradiction. Then I hope to finish up with something that's very, well, to me was surprising, but I guess I really shouldn't have been surprised. But there's a guy, Victor Schatz, who has essentially developed a very similar theory to mine. So there's another guy out there that has a theory like my theory. So I don't really think I've been scooped, but if I get a chance to talk about it, his theory is he has ideas very similar to mine.
Does he quote your papers?
No, he doesn't even know I exist. Neither did I know that he knew that he existed. Okay.
Another victory for scholarship in science.
Yes, you could sort of say that. On the other hand, um, people in the CNPS have pretty much ignored everything that I've ever said, and I guess that's an even bigger failure because the opportunity to build on my work has been there for the last 20 years, and nobody's ever bothered to do that. So I'm not sure what that says. So it takes some guy from Berlin who's apparently a Russian guy and uh, who writes in German, and then when translated into English, it's very horrible to read. Okay, correcting Einstein's math paradoxes resolved. So I'm going to show how we can sort of fix the paradox problem. Turns out that it's a mathematical thing to a certain extent. It's kind of like how you interpret how to deal with the mathematics. And but in reality, you could sort of look at it as the reason that they don't really look at the mathematics correctly or do the mathematics correctly is because they're imbued with this Einstein metaphysical ideas about time and space being mixed up. I don't think time and space is mixed up. I think physics is mixed up, and people who believe it are mixed up. Okay, the paradoxes of relativity result from math mistakes. Okay, and I've talked about this before. The main mistakes will be explained and the mathematics will be corrected and examples presented to show how the contradictions, which they call paradoxes, are how we can correct those. Okay, paradoxes are math contradictions. The paradoxes are mathematical thought problems, like exercises in textbooks. So they present these as like these are exercises in correct thinking. Exercises in correct thinking. The correct answer is dependent upon what the expert teacher believes is the correct answer. So these are taught by the professors, who are going to tell you what the textbook answer ought to be. It's typical pedagogical method. Okay, so in special relativity, mathematical contradictions. Okay, these are things where if you have a mathematic contradiction in mathematics, that means that your theorem is disproved or your proposition is disproved. That's not the way they view things in physics, apparently. Um, so they're called paradoxes, using the definition of a paradox as a seeming contradiction. So a paradox isn't really a contradiction. It's not an invalidation. It only appears to be. Calling the contradictions paradoxes is an attempt to immunize the mathematical contradictions according to the accepted principles. We'll talk about some of the ways they attempt to explain the problem away. And then my claim is that these issues arise because they're doing the mathematics incorrectly. If they did the mathematics correctly, there'd be no paradoxes or contradictions. And but then they'd have a problem in that their theory wouldn't be consistent with Einstein's metaphysics. Now, Roger talked about Einstein's metaphysics and Lorentz's metaphysics yesterday. Okay, so I'm going to kind of talk about, turns out this is kind of a funny thing. There's tons and tons of paradoxes. And they're just everywhere. And the more I looked, the more I found. Now, you would think that would be a big red flag. Apparently not. Okay, so I'm going to talk about the first kind. These are the serious ones. Contradictions arising because of the principle of relativity and the assumption regarding the creation of the inverse Lorentz transformation. These are basic mathematics. These are real big, these are biggie contradictions. Okay, so what Einstein did was he applied the principle of relativity to the Lorentz transform. And he said, well, all we have to do is by symmetry, because we have symmetry according to the relativity principle, we just change the variables. We'll change x to x prime and t to t prime, and we'll just change the signs from minus to plus and plus to minus. And then we've got this Lorentz transfer, inverse Lorentz transformation. Well, it turns out that's completely wrong. Okay.
Just a quick preemptive question, if I may. What does symmetry? Where is symmetry found in relativity?
Well, by the principle of relativity, inertial frames are related by symmetry. So every inertial frame is related to the other inertial frame by the same laws of physics. So
okay, I got it. Thank you. Yeah.
Okay.
Sorry, just a piece of housekeeping, Harry. On the right-hand side of my screen, there's a little properties which giving all the layouts. I wonder, can you get rid of that by just crossing the X?
I forget how to do that.
Yeah.
I think I need to go to full screen.
It'd be a little better.
I don't know how I go to full screen. See, I don't.
Try slideshow.
Well, where it says properties, there is an X, and I think Ian was referring to or the owner.
It was, yes.
Today we are owned by Ian.
All right, but now I've screwed up because now I have to go to the next slide. Okay.
Arrow keys.
You go to the thumbnails as well.
Yeah, let's hope. Is this good for everybody? Okay, so here's what the problem is. The problem is this thing called evaluation. All right, and contradictions and what they do is they don't really pay attention to the mathematics and how the mathematics works. And so you have this, and I've talked about evaluation before, and to them it's just kind of like it's not really well defined in physics what they're talking about, and it's not a clearly defined procedure. But what it boils down to is where you pick simultaneous in time or coincidence in space. So when you do things, you specify a condition. Or are we talking about events that happen at the same place or events that happen at the same time? And what to specify events at the same place, you say x equals 0. And that means events at the same place in the rest frame. And then x prime equals 0 means events at the same place in the moving frame or the prime frame. Okay, then t equals 0 means events at the same time in the rest frame, and t prime equals 0 means events at the same time in the moving frame. Okay, now what they do is they mix up these evaluation criteria, okay? And so what happens is that the math doesn't work because you can't transform from one frame to the other frame unless you use the same evaluation condition going to the frames back and forth. Okay. Then you have, okay, here's another one where you run into this problem where there's a whole bunch of paradoxes involving force calculation, relativistic statics. And the first one that was discovered was what's called the lever paradox. And what happened was when they have a lever and the forces on the lever's at right angles. And so they calculate forces in different directions. Well, it turns out that if the forces are in equilibrium when the right angle lever is at rest, they're not in equilibrium when the lever is in motion. And so that's a typical problem that arises in doing relativity calculations. And so those are called paradoxes in relativistic statics. Those arise because the evaluation conditions that are used when calculating the force and the length contraction are different. They don't use consistent criteria. This is the whole point. The criteria that are being used, these evaluation criteria, are not consistent when they do the calculations. Then there's a fourth one down here at the bottom. It turns out, and this is an interesting paradox, and I didn't know about this, but it turns out that if you talk about an object that's sliding on a rail, and you calculate the frictional force in the rest frame, and then you calculate the force in the frame of the object that's sliding on the rail, you get a different friction. The friction is different because the force is different. And so that's a contradiction. Why would the dissipation of energy, the energy that's required to move, is different? Okay, well, anyway, I'm not going to talk about that too much, but it's surprising. All right, now I'm not getting to the next. You're going to have to help me here. It's not moving to the next slide. I knew this was going to happen.
Try right clicking on the. Try right clicking and see.
There we go. Okay, here's the next one. See, now I've screwed up. Okay. How do I get out of this? Okay, another failure.
Well, if you go to slideshow, but I guess
I don't know. How do I go to slideshow?
Well-
It's right at the top, next to tools.
view,
Other direction.
Even view normal.
Might do because it's
there. I think slideshow was in the view menu. About
no, it's right at the top there.
I'm not using Microsoft.
Oh, that's slide P.
Oh, okay. You see, you've got notes page there. Just view normal, the very first one there. Go back to view and just click the first entry. Normal. That's it. Try that.
All right. Okay, so now I'm going to do view slide bar. That didn't help. All right. Okay. So this is the first slide. So I'm still messed up. All right. So you screwed me up, Ian, when you asked me to increase the screen
I was
size.
trying to help. Are your arrows not working? Your up and down arrows.
No, it just moves the all right.
Try either space bar or enter, see if either of those works.
No. No, it's not moving it
You
forward.
may have to go back to the view window and show the slide.
All right.
Now
my
start again, Harry.
my machine is confused now. All right. Slide 1. Slide 2.
Work now, yes.
All right. Now, okay. Everybody see this? This is good for
That
everybody.
is the
Yeah.
best view.
It is.
All right. The next, so I talked a little bit about the different types. There's many, many, many. There's Bell's spaceship paradox. You may have heard of that. And that's one of the ones in the relativistic statics. There's all these different, it's like the guys sit around and try to invent paradoxes and then explain why they're not paradoxes. Okay, so the usual immunization, that's, the way they explain, it's not really a paradox. It's Bob said the word is immunization, or they make it so that there's a principle that applies that means that it's not really a contradiction. So the relativity of the simultaneity is their favorite. Now, I'm not really sure what that means. Okay, there's another way they avoid the paradoxes, and this is the one that they use again. That famously Bourne said that Dingle's arguments were wrong. I'll talk about Dingle later. He said the math symbols don't mean the same thing. And then, like, what do you mean the math symbols have different meanings? What does that mean? That seems like a dodge. The other one used to refute Dingle is the physical situation supposed to produce the contradiction is mathematically impossible. That's they use that against Dingle because they said, well, it's impossible for clock A to run slower than clock B and clock B to run slower than clock A because math says that can't happen. And you say to yourself, well, wait a minute, didn't relativity predict that could happen? And now you're saying that the math says that it can't happen? I guess basically what they figured was nobody was really going to look at their, how would you say, their argument for getting rid of the paradox. And then this is the favorite one. People don't understand relativity. Okay, for force type paradoxes, this is a continuation. What they did in the case of the lever, and they said, well, and when you're moving at high speeds, there's an unknown force that comes into being that fixes the paradox and balances the lever. So, and this also happens in electrodynamics, where the new physics is invoked to explain the paradox. All right, I'm just mentioning those things. I don't know if any of you are familiar with them. I'm really only going to focus now on some of the other issues. Now, here's the problem I have with relativity of simultaneity. Relativity of simultaneity is taken into account through the evaluation conditions, the t and t prime equals 0. So that's you've already assumed that events are simultaneous in one of the frames. Okay. And then they say, well, but these events are not simultaneous in the other frame. Well, that's what the Lorentz transform says. So essentially the relativity of simultaneity is what causes length contraction according to special relativity. It makes the unit length appear longer, okay, or shorter, okay, depending upon the evaluation conditions. Now, in my view, it's contradictory to say that the paradox is removed by relativity of simultaneity. You know, it's like invoking what caused the paradox to explain the paradox. Does that make sense to you? That's so I don't really understand what they're talking about. It just to me seems like what they're doing is just they've created a catchphrase, relativity of simultaneity explained. So they're citing a catchphrase. It doesn't really remove the paradox or explain the paradox. It's just a catchphrase. And there are other catchphrases like relativity is correct because thousands of experiments prove it. You know, it's just a catchphrase. So I don't understand that.
I've yet to see even one of these thousands of experiments that uniquely endorse special relativity over other theories. Not even one. I haven't seen one of those thousands of experiments that everyone talks about.
Right, I agree. All right, I'm going to talk now about Dingell's paradox. I probably spent too much time talking. I'm going to run out of time here pretty quick. Dingell's paradox, and Dingell came, he didn't actually invent this paradox, but he published a lot of papers about it and created a kind of a big dust up, and that's kind of how he got, we're going to call it Dingell's paradox. But his paradox is that if you have two clocks A and B moving with velocity relative to each other, clock B runs slower than clock A, and by the relativity principle of symmetry, clock A runs slower than clock B. So clock B runs slower than A, and A runs slower than B. And then, when you put this into, B less than A less than B cannot both be true. That's a contradiction. That's this equation here. You can't have that equation to be correct. Okay, that's an incorrect equation. It defies logic. Okay, and so here's the point here now is we have these two equations, T prime equals beta T, where beta is a Lorentz factor and T equals beta T prime. When you solve these equations, one clock is slower than the other, and then the other equation says the opposite thing is true. Okay, now that's where the math mistake is, basically. That's the math mistake. These two equations here results from the contradictory equations. Those equations are incorrect. Okay, you can't have both of those equations simultaneously be true. All right. Now, here's a solution. We're going to get these bijective equations. Bijective means one-to-one and onto, and it means it's provably correct mathematics. So the correct equation is T prime equals beta T, and T equals beta T prime. Now, these are the basis transformation laws that I've talked about in previous presentations. When we do the logic, we get B less than A and A greater than B, not a contradiction in logic. So this doesn't contradict anything. There's no contradiction in this equation. The equations T prime equals beta T, T equals beta T prime, they have no solutions actually in formal mathematics. So the only solution that you have is what's called the trivial solution. So if a mathematician was looking at this without knowing anything about relativity and all the other BS associated with it, he'd say this is not good mathematics. Okay, the contradiction, here's the point. Contradiction occurs because the two equations are solved by incompatible evaluation conditions, x equals 0 and x prime equals 0. So one equation, the first equation is solved for x equals 0. The second equation is solved for x prime equals 0. Okay, you can't do that. That's the problem. Okay, so to make the long story short, when Dingell pointed this out, that there was this contradiction, they say, well, there's relativity of simultaneity. There's your equations don't make any sense because your math is impossible. And you don't really understand the relativity, and the symbols don't mean the same things in the two different equations. So different people, there's a whole array of excuses. And so his problem got ignored. Okay, so here's the solution. The evaluation conditions applied are symmetrical to the Lorentz and the inverse Lorentz transformation and result in equations of the form t equals beta t and t equals beta t prime. And I said this before in the previous slide. Okay, these equations have no common solution except for the trivial solution b equals 0 when velocity is 0. So if we put b equals 0, beta equals 0, oh yeah, the solution, there's a solution that exists, but it's a meaningless solution because there's no relative movement. Okay, there are no valid solutions to these equations. Now, what's interesting is the relativists proved that Dingle was wrong by agreeing with this. That's very difficult to explain, but it's ironic. Okay, here's the point. We need a bijective transformation. Okay, the bijective transformation. We need a one-to-one and onto transformation to get from the rest frame to the moving frame, or from unprimed frame to prime frame, and then from prime frame back to unprimed frame. Okay, we need a bijective transformation. If we have a bijective transformation, there's no paradox. Okay, a bijection is a one-to-one and onto, which means that it's uniquely true and rigorously correct. Specifies a uniquely true transformation. So here's the problem right here. They're not using, in relativity, they don't use uniquely true, rigorously correct transformations. They're not bijections. Relativity does not use bijections. Bijection is the holy grail of mathematics. That's how you prove things are true in mathematics. You use bijective transformations. You use mathematics that's bijective. That means, and I don't know if you're familiar, but they use the term sufficient and necessary conditions. They also use one-to-one and onto. They also use uniqueness. It's unique. They prove uniqueness. So there's different, how should I say, terminology or terms that mathematicians use. But if you look at a math book, whenever they prove a theorem, they prove one-to-one and onto, necessary and sufficient conditions. Okay, you have to prove these things in mathematics in order to get correct mathematics. They don't do this in relativity. None of this is proved in special relativity. They don't prove that any of the Lorentz transformations used by special relativity are one-to-one and onto and are bijective. They're not. That's why the paradoxes appear. Okay. The bijection requires a time transformation for a clock at a fixed position, transforms time into the moving frame and back, giving the same answer as at the beginning. Okay, so what happens is, what bijection means is that if you start from point A, or an event A in the rest frame, and you transform that into a time or distance in the moving frame, then you can take the results that you get in the moving frame and transform them back to the rest frame and get the same answer. Paradoxes arise because when you do this procedure of transforming from the rest frame to the moving frame and from the moving frame back to the rest frame, you don't get the same answer that you started with in the rest frame. That's what the paradoxes are. Okay. The ladder paradox is an example of this, where they say there's a ladder that has a certain length in the rest frame, and they say, what the question is, does the ladder fit in the garage that it's supposed to go into? And when they transform this into the moving frame, okay, the ladder becomes shorter because of length contraction. Okay, but when they're in the moving frame, the barn gets contracted and the ladder won't fit. So the ladder can't fit All right. And anyway, that's the latter paradox. I'm going to talk about that more in detail a little bit later. Okay. Bijective transformation. The transformation therefore requires evaluation condition to be the same for the transformation and its inverse. But what that means is when you transform from the moving from the rest frame, you say x equals 0, okay, or t equals 0. That says that the events are coincident in place and simultaneous in time, and you transform them into the other frame. When you're going back, you have to say x equals 0 again to go back. And what they do is they say x prime equals 0 to go back. Okay, so the correct way to do it is x equals 0 going from the rest frame to the moving frame, x equals 0 going back from the moving frame from the rest frame. But what they do is they change evaluation conditions in the middle and get the wrong answer. Okay, so that's the key point. You have to use the correct evaluation conditions, and special relativity do not solve the problem using the correct evaluation conditions. Okay, and so at the bottom, all right, we get when we do this, when we use x equals 0, transforming from the rest frame to the moving frame, and we use x equals 0 going back, we get back to the same condition. We say we want to start with the conditions x equals 0, and we want to have the conditions be the same going in the opposite direction, so we get the same result. Okay, so now we get these equations. T prime equals beta t, and t equals t prime divided by beta, which is the basis transformation law. And it's a bijective transformation, meaning it's one-to-one and onto, means that satisfies the sufficient and necessary conditions, and therefore it's correct mathematics. Okay. Okay, so here's the problem in the, has to do with the inverse Lorentz transform. They think that when you're going from the moving frame to the rest frame, you choose x equals 0. Okay, but when you're going from the inverse, using the inverse Lorentz transform, going from the moving frame back, you choose x prime equals 0. Okay, and that doesn't work. That causes the paradoxes. Okay, now if we're in the dual transformation and we choose x prime equals 0 going in both directions, in other words, we choose x prime equals 0 in the inverse Lorentz transformation, and we also solve x prime equals 0 in the Lorentz transformation, we'll get these two equations which form a bijective pair. Okay, so this is the coordinate transformation laws. These are the bijective coordinate transformation laws, and they're not contradictory. What you have are two bijections. You have a bijection, which is a one-to-one and onto transformation that creates the basis transformation laws in the Lorentz transformation. And in the using the dual transform, I'm not going to call it the Lorentz transformation because it's not the, I'm sorry, inverse transformation. It's not an inverse transformation. It's not an inverse transformation. It's incorrectly named, okay? And they're using it incorrectly because they think it's an inverse, but it doesn't give you the bijective transformations that you need. Okay, so we have a set of bijective transformations for the basis transformation laws, and those are defined by the Lorentz transformation, and we get another set for the dual transformation, and those define the coordinate transforms. Okay, so we have the bijective coordinate transformation laws. They're not contradictory. And we have the basis transformation bijections, and they're not contradictory. So that's basically how it ought to be done, but they don't do that. Okay. All right. I'm going to talk a little bit about the lever paradox. It's a complicated, there's a big, massive literature. If you go, there's probably hundreds of papers written on the lever paradox that people said, oh, okay. It turns out, interestingly enough, that this is probably the oldest paradox. I can't swear to that, but I believe this was published in 1910 or 11. And that kind of makes it pretty old. And I explained that briefly about that the lever is in equilibrium in the rest frame. There's a force on one arm of the lever and there's a force on the other arm of the lever. And they balance out in the rest frame, but they don't balance out in the moving frame. Okay. And this was solved by Hasio by I. And that's really kind of important because he shows that there are 4 different ways to solve the paradox. The 4 different ways essentially boil down to the 4 transformation laws that I have been talking about. There are 2, the ones that are there's a pair for the basis transformation and there's a pair for the coordinate transformation. There's 4 different equations that you have. And he shows there's 4 of these different equations. Okay. And the forces on the arms of the lever are not equal according to special relativity. So according to special relativity, when you solve this problem, the forces are not equal when the lever is in motion, but they are equal when the lever is at rest. Okay, and then they say, oh, there's this fictitious force in the moving frame that keeps the lever in stasis or in equilibrium. So they've invented a fictitious force to resolve the paradox. Okay, now how did Hasio by I resolve this paradox? How did he resolve it? Well, what he did was he used the same evaluation conditions consistently. Okay, so when he used the correct evaluation condition, x equals 0, x prime equals 0. He used that in the correct transformation. So he used it correctly when he derived the transformations. He did the evaluation correctly. Okay. And unfortunately, not many people paid attention to him. Okay, so there are 4 cases. He solved the 4 cases, resolved the lever paradox in every one of these cases because you get different laws. You get the basis transform law, you get the inverse basis transform law, you get the coordinate transform law and the inverse coordinate transform. He solved it for all those cases consistently and showed that the lever paradox didn't exist. He got that the conditions were in equilibrium for all of the cases. So he got 4 solutions for the 4 transformations. I borrowed this idea that there are 4 transformations. That's where the 4 transformations come from. And you get the 4 equations. Here they are. L prime equals beta L, L equals beta, L prime divided by beta. That's the first bijective pair. Important, this word bijection is important. 1-to-1 and onto, necessary and sufficient conditions. And then you get the other second bijective pair. Okay, L prime, okay. 1-to-1 and onto and necessary and sufficient conditions. So we're going to get cut off here, got less than a minute. Okay, now what the problem with his paper was that he'd solved the problem, but his explanation of how he solved it was very obscure because he didn't have the idea of the different transformation laws, the basis transformation law and the coordinate transformation law. He didn't have that idea. Although he had solved the paradox correctly, he didn't really have the correct explanation of it. He did. He failed to recognize the 2 pairs involved physically. In other words, part of the problem is that the symbols that they use, the x and the x prime, they don't have the same meaning. Well, this is interesting. Okay, welcome back. Something strange is happening here. Okay. I'm going to go on to the next slide. Now the slideshow isn't working. Oh. Okay. All right. So now we're at the conclusions. I talked a bit too much. The Dingle paradox and the twin paradox. I didn't talk about the twin paradox because that's a complete mess. Are the only ones that challenge the correctness of SR. So they're both the Dingle paradox and the twin paradox are basically similar in that the paradox is that the clocks run slower than each other. Okay, so clock A runs slower than B, and B runs slower than A. And that doesn't make any sense because that produces a logical contradiction. That's the same thing as the twin paradox. But in the twin paradox, they claim that the twin returns younger. But then the argument is, if that's the case, why isn't the aging of the twin symmetrical, and he shouldn't return older? Okay, that's a complicated. But anyway, that's a problem for SR. Okay, that they've managed to sidestep for over 100 years by making all. Einstein says, well, it's the twin paradox is resolved by acceleration. Okay, here's the main point I'm trying to make here. The paradoxes arise because of incorrect conclusions deduced from mathematics used in special relativity. So they're incorrect they achieve incorrect conclusions. They say they deduce incorrect things, okay, but they say they're not really a problem. They're not really a paradox, okay, by their immunization arguments. Well, there's relativity of simultaneity. You have to consider that. Well, you don't really understand relativity. It's too. Okay, so the paradoxes illuminate contradictions or mathematical mistakes. So they are contradictions and mathematical mistakes. I skipped the frame here. Twin paradox removed when calculating and moving in rest frames. Okay, unfortunately, I skipped over this. Okay, so they say acceleration. So if we do the evaluation correctly, there's no twin paradox. That's the point. The calculation that what they do is they're using the wrong mathematics. They're not using bijective transformations, meaning they're not one-to-one and onto, which means they're not rigorously correct. Okay, if your transformations are not one-to-one and onto, that means you don't have sufficient and necessary conditions. That means that you haven't proved uniqueness. That means basically you're using bad mathematics. Okay. They don't take into account that there is a change in the units in the calculation of the time and space. So you have to take into account that there's units are changing and the number of measured units are changing, and they're not doing the physics correctly. The physics of measurement is not being done correctly, and the mathematics is not being done correctly. So there's two main issues there. And Einstein assumes there's no change in the units, and so that means two of the transformations, the equations, don't have any really correct physical meaning in Einstein's theory. So he's not really doing the physics correctly, the physics of measurement. He's not doing that correctly. And because he didn't do the physics correctly and he made incorrect assumptions about metaphysics, they're using the wrong mathematics. Their mathematics isn't correct mathematics. It's not rigorous, correct, provably correct mathematics. It's flaky mathematics. So when we fix the change in the time units, that the time units are changing and that the number of time units are counted, that we get that the time is the same. I talked about this in previous presentations. The ladder paradox are resolved by using the correct evaluation conditions, because what happens in the ladder paradox is that you get that one observer sees the ladder is too short, the other observer sees that the barn or the garage is too short, and it's kind of a confusing argument. You sort of wonder why are they talking about this confusing thing? And they're doing it so they can say, well, the relativity of simultaneity is why these confusing results are happening. But it's not really clear to me why the relativity of simultaneity even enters into it at all. Okay, and so that's the end of that presentation. So does anybody have any questions? I went over it pretty fast because I've got more to talk about.
Well, I wrote down quite a few things in the chat. Well, you know, we've had conversations about the relativity principle many times, and I don't see how it's mistaken, though. I mean,
I'm sorry, it doesn't produce the correct results.
why doesn't it though? I mean, I can understand why.
Well, you're asking, like as usual, Jerry. You're asking me questions like, why does the world exist? You know, I don't know.
No, it isn't like that at all. Oh, you want me to read what I have?
Well, you're saying, I mean, I'm just saying the relativity principle doesn't work when they apply it to these paradoxes, and that's just what the problem is.
Yeah,
and so Einstein basically did his math wrong. Okay, he applied the relativity principle and it came up with the wrong math. And so he shouldn't have applied the relativity principle. Maybe the relativity principle is correct, but he just messed up when he used it. I think this discussion came up yesterday.
Well, I can see how you might want a preferred frame if you're conducting an experiment, and you have to use one frame at a time. However, though, if you choose whatever frame that it is, that's sort of what he means by the principle of relativity, is that you can choose any frame and you'll get the same result.
Well, you don't. That's the whole point of the paradoxes.
If you choose one frame,
it doesn't work out.
That way, and you choose another frame,
well, it doesn't work out. That's the problem.
Let me read what I have. My view is that the principle of relativity is a correct observation of the relative frames of objects. When a frame is either stationary or travels at a constant velocity, it creates an equilibrium where the laws of physics are the same. The main factor is that there is no accelerations. The paradoxes or contradictions arise because they wanted to find a consistent way to account for the invariance of C. They might have theorized.
You're just rehashing relativity, okay? You're just rehashing.
I'm making a point. The contradictions and paradoxes arise because they want to account for the invariance of C. They might have theorized that Newton's equation, distance equals velocity times time, didn't apply when the object or observer travels fast relative to the light source, or vice versa.
Well, you're just rehashing what relativists say.
No, this isn't what relativity says at all. I'm disagreeing with relativity.
Well, but you're confused, because essentially what the whole point of this is that by applying this principle of relativity as Einstein does in the way he does it, it doesn't produce correct mathematics.
Why are the Lorentz transformations necessary?
Well, the Lorentz transformations are used in high energy physics. Okay, so then you can say, okay, the Lorentz transformations turn out to be useful, okay, in physics. The problem is they did the math wrong.
Yeah,
you don't understand that? Do you?
No, I understand. You believe that the units of measurements transform.
If you do that,
why would they?
If you say the units of measurement and then the measurement coordinates of measurement, Okay. If you use that, you get no paradoxes and no contradictions, and you get no mysticism, and you get no bad mathematics. You
What
get rid
what
of
what
all
why,
these paradoxes.
why do
So
you think that
something is wrong in their thinking.
yeah. Why do you think the Lorentz transformations were invented in the first place?
Well, they were discovered by Voigt, who wanted to make the equations consistent, as I recall. So,
With relative motions of objects. When they travel fast, Newton's equation doesn't apply, and they felt they had to reorder existence in order to account for the invariance of C.
so what's your point?
I just said it.
No, you didn't say anything. You just cited what the
Never mind, Harry. Go ahead. Go ahead with your presentation.
I don't understand what your point is. What's your point?
What if the invariance of C is just a misunderstood anomaly of the universe? And if it isn't true, what is the point of the Lorentz transformations in the first place? They were designed to account for the invariance of C. That's what I've read all the time. If there's another reason for their existence, please tell me.
Well, I'll explain it to you in very simple terms. The Lorentz theory is the correct theory, and Einstein's theory is wrong.
Okay, thanks for your very enlightening assessment
We
there.
discussed that yesterday, and Roger presented a really ridiculous, oh, AI said this. I disagree with what AI said here. Oh, AI says this. That didn't make any sense. Okay, the
I would
bottom.
counter, if I may, the contention that the Lorentz transformations were developed to substantiate the invariance of C. No, quite the
I don't know
contrary.
what that.
That
I
was a
don't know what that
consequence.
means. I
Yeah,
don't
oh,
know
I
what
thought
that
Jerry
means.
said that.
I know he said that, but I have no idea what he means when he says that.
Well, I'm countering it anyway. I say that that comes out of the equations. It comes out of the wash. It's not put in there. It's a price you have to pay if you introduce these transformation equations. Well, then you have to pay the price that irrespective of the motion of a receiver towards a source, the speed of the received radiation is invariant. That's a very big price to pay, I believe.
Well, I
Well,
think it's only invariant in the Lorentz theory because essentially GPS assumes that the speed of light is invariant in the ECI. And then when they do the Sagnac correction effect, the speed of light in the ECI is constant after you correct for the motion of the Earth relative to the satellite.
Well, how far does the ECI extend?
Well, as far as they have GPS satellites,
So that's where it ends?
I didn't say that.
Well, it's what you said.
Well, you're
How
just
far does it
you're
extend then?
you're just playing with
Well,
words.
how far does it extend? It's a simple question. I
I,
mean, I've read that it extends
as
infinitely,
far
so
as
that means that
as
C is
far as the
invariant everywhere.
satellites, as far as the satellites.
So the ECI frame stops as far as the satellites go.
No, we only know that it extends as far as the satellites. You're just hypothesizing.
Yeah, no, but you said that C is invariant within the ECI frame. I've read the ECI frame extends infinitely into all directions.
Well, you don't know that. I don't know that, and whoever said that doesn't know that.
I can understand that the Earth's sphere of influence of gravity extends certain far, but it gradually fades, and maybe it just extends infinitely, but it just gets weaker and weaker the further it goes out.
Well, you're speculating. As far as I know, there are no measurements on this. All we know is that the system works according to the rules that they've set up within for the satellites that they have that are fairly close to the Earth. And to speculate on how far it extends out beyond that, where there are no measurements to tell you anything, I can't answer that.
Okay.
But if you conceive of an ether, being linked to the Earth in gravitational or electromagnetic ways, it would be rational to assume that the attraction of the Earth on this ether would diminish. Not suddenly, but would diminish with distance. And this is what the Miller experiments were doing, because he was doing to see was there any ether drag at the top of Mount Wilson, in contradistinction to what Michelson-Morley did, where they were effectively on the surface of the Earth, and he did apparently find a drift.
Ian, don't you disagree with the Lorentz transformations, though?
Yeah, I don't know what its terms you use, agree or disagree. Look, Jerry, I don't accept the Lorentz transformations. Do I use them? I might be prepared to use them once or twice because they're like a mathematical trick. It's almost like when I'm solving the differential equations for circulation of planetary objects. I'm doing it in terms of r, the radius vector length. Well, there's a well-known mathematical trick where you substitute the value u, which is the reciprocal of r, into it, and the equations just get very, very simple, and you can solve them. But you don't need to do that. It's a bit of a mathematical trick. The Lorentz transformations are an unnecessary. So I've gone off now. Can you still hear me?
Yeah.
Yes.
Yeah.
Okay, it's just that Harry has put the thing on. Yeah.
Well,
So,
I mean,
yeah, so to answer your question, I don't agree with the Lorentz transformations. They're really Oshios is the term I use. They're just lazy, irrelevant. If you look at the proper mathematics, you don't need them. The proper mathematics being the equations of fluid dynamics.
Okay, I'm going to talk about the ladder paradox a little bit here. Here, the ladder paradox will be discussed from the perspective of what can be inferred regarding its conclusions. Different ways of interpretation of the paradox will be formulated with the objective of ascertaining whether it falls into a philosophy of idealism or realism. Okay, so what I'm trying to say here is we're going to run into a real problem with what does it mean, length contraction? What does that really mean? Is it real or is it not real? Okay.
I don't think it's real.
Huh?
It's a shortening of objects when they travel fast relative to another frame.
So you think that's real? So that would
Well,
be realism.
I don't think that's real at all. And it's a paradox. And, fortunately, it isn't true. So we don't have to worry about it, really.
Well, that's I seem to, all right. I seem to have started in the wrong place here. Okay, so the ladder paradox, it's a thought experiment. Okay, so it's not a real thing. It's just a thought experiment. And it presents these mathematical conclusions. So yeah, it's not really real. So what does it mean really? It's a typical example of a class of paradoxes which involve length contraction, claim of special relativity. Okay, so length contraction, I think, is wrong. And that's kind of where a lot of the problems arise. The main paradox is that when the mathematical Lorentz transform equations are solved, the results are different and contradictory for each different observer in an inertial frame. Okay, so what does it mean to have observers in different frames? Not clear. Okay, it involves a ladder parallel to the ground, traveling horizontally at relativistic speed, undergoing a Lorentz length contraction. The ladder is imagined passing through the open front and rear doors of a garage or barn, which is shorter than its rest length, so that the ladder was not moving. If the ladder was not moving, it would not be able to fit inside. So I don't really, this is where it kind of becomes, why would you want to fit a ladder moving close to the speed of light inside a garage? Doesn't make much sense. That's where it becomes a thought experiment. Okay. So the ladder is imagined passing through the open front and rear doors of a garage or barn, which is shorter than its rest length. So the assumption at the beginning is the ladder is too long to fit in the barn. So if the ladder was not moving, it would not be able to fit inside. To a stationary observer, due to the contraction, the moving ladder is able to fit entirely inside the building as it passes through. because of length contraction. Okay. So the ladder is too long to fit, okay, when it's at rest. But when it's moving, it's Lorentz contracted and now it can fit. Okay. On the other hand, from the point of view of an observer moving with the ladder will not be contracted. And it is the building which will be Lorentz contracted to an even smaller length. Okay. So from a guy who's moving with the ladder, the building is too small, so the ladder won't fit. But that agreed with our initial assumption that the ladder was too long. Therefore, the ladder will not be able to fit inside the building as it passes through. This poses an apparent discrepancy between the realities of both observers. Okay, now this comes out of, I copied this from Wikipedia. So this is kind of like the official, this poses an apparent discrepancy between the realities of both observers. What is that? What do they mean by reality? Okay, so then here comes, this is a summary of the conclusion that they give. This apparent paradox results from the mistaken assumption of absolute simultaneity. Well, why is that a mistaken assumption? They don't explain that. The ladder is said to fit into the garage if both of its ends can be made to be simultaneously inside the garage. That's where this relativity of simultaneity comes in. The paradox is resolved when it is considered that in relativity, simultaneity is relative to each observer, making the answer to whether the ladder fits inside the garage also relative to each of them. So this is not only a paradox, it's philosophical confusion. This is relativity. They actually think this is some kind of a meaningful discussion. Okay. I think this claim about the relativity of simultaneity, this is my view, is a red herring to distract from the main problem revealed by the thought experiment. Okay, so what's the real problem? The real problem is they're doing the calculations wrong. Okay. The red herring is the ambiguity of whether the Lorentz equations predict Lorentz contraction is real or only an observer perception effect. Okay, so you have this problem now of if the contraction of the ladder, if Lorentz contraction is real, that means the ladder is actually shrinks when it's moving, but the observer on the ladder doesn't see the ladder shrinks when it's moving. He doesn't see a change in its length at all. So that doesn't really make a whole lot of sense. What does that mean? So is Lorentz contraction real or is it not real? And what's kind of interesting about the whole way it's presented is it's kind of assumed to be real the way they talk about it. So they talk about it as if Lorentz contraction is real, but then in the middle they switch and they tell you that it's really not real. And the solution.
You can do this sort of thing in cartoons.
Yeah, I think the whole theory is a cartoon. You're getting the point, Jim. It's kind of you might have, as Ian says, he doesn't like the Lorentz transform. I don't think there's a problem with the Lorentz transform so much as it's a problem with the way physicists think about what it means. I don't think they have a clear idea of what it means. Okay, so the point is, you're kind of left befuddled as to, you're talking about an engineering problem, it seems, at the beginning, and then it turns out you're not really talking about. It's just an imaginary. It's just a thing, and it's a thing in the mind. It's just. So that's kind of an idealism, it's just a thought experiment. So is the problem real or is it a thought about a real situation? Is this something real? No, we're not really sure. We don't know. Okay. The solution suggested that time is not absolute, negates the principle that science is about the real world. Okay. This is where I have a philosophical issue with relativity. So if you're saying that time is not absolute and space is not absolute, and then you can apply relativity and say relativity is correct, but relativity tells you that there's no reality to reality. So reality isn't real. It's all just an illusion, or maybe not. The principle is used to make the prediction of length contraction. So in other words, what are they really talking about here? It doesn't really make any sense. When it is used to imply that the conclusion that length contraction is real is false, there being no real contraction is only an illusion of the observer's perspective. So why are we talking about Lorentz contraction if it turns out that it's only an illusion of the observer's perspective? What's the whole point of this exercise, this thought experiment, if Lorentz contraction is illusion? If it's an illusion and the ladder is longer than the garage, it'll never fit. And we already knew that before we started to think about the problem. So the problem is kind of pointless. All right. So my point is here, and I was trying to get to this, is that the real paradox isn't really the paradox, because the paradox can be solved using the correct equations, which I discussed earlier. The paradox is, what are we talking about? Are we talking about something that's real, which would mean we're talking about realism? It's real. The ladder is longer than the garage that it's supposed to fit in, and we know it can't fit in the garage. Okay. But if we apply relativity, relativity says that under one condition, the ladder is moving fast, it's not at rest, it can fit in the garage. Okay. But then if we reverse perspective and look at it from the moving observer's perspective, the garage is too small and the ladder can't fit in the garage anymore. So what are we left with? Just confusion, something that doesn't make any sense. And so we start by postulating length contraction is real by the mechanism of apparently solving a real physical problem as in engineering. Will the ladder fit in the garage? So that's the question. Is it going to fit in the garage? Well, we know the ladder's too long by the initial assumption. The answer is, of course, no. It's clearly too long according to the initial assumption. Yeah. Why are we even talking about it when we know the ladder's too long? Length contraction is evoked to argue that according to special relativity, it will not be too long, contradicting common sense. No, that doesn't make any sense. But this is only one observer's opinion of the result. The other observer, now from the other observer's viewpoint, moving with the ladder, the garage is too short for the ladder to fit, in agreement with the initial assumption that the ladder is too long to fit. The claim is this poses an apparent discrepancy between the realities of both observers, but not a contradiction of the starting assumption that the ladder is too long to fit. Okay, so maybe I'm getting confused here, but this is just a confusing example. The ladder is too long to fit. Okay, and we knew that at the start. Why did we go through all this rigmarole to really basically initiate confusion? Why are we even talking about this? It's a thought experiment in special relativity is really the point. But does the thought experiment actually prove anything? What is the point of doing this whole experiment?
I think the thought experiment disproves length contraction.
That would be my conclusion. But Einstein, as I pointed out in a previous discussion, Einstein talks about length contraction in two different ways. Okay, and so in some places he implies that it's real, in some places he implies that it's not real. He does the same thing with time dilation. So you never really know whether what he's talking about is a real physical thing or just an imaginary physical thing. By imaginary, I mean it's something that the observer thinks is happening, but it's not really happening. Okay, all right. The main conclusion is that not only the moving observer correctly deduces that only the moving observer correctly deduces that the ladder is too long to fit. Okay, well, that doesn't make any sense. The rest observer can deduce the correct ladder length using the equation. Now, here's the point. If If we use the correct mathematics, the rest observer can deduce the correct ladder length using the equation L equals beta L prime to obtain the correct length of the ladder from which he can deduce its correct length. So in other words, it's not really a problem. This doesn't really exist if you use the right mathematics, either by the bijective laws that I talked about. If you use those correct equations, you don't get any of this confusing nonsense. And of course, in my theory, it turns out there is no actual length contraction. That's only a artifact of the way the Lorentz transformation is misused in special relativity. What Lorentz the ladder contraction means that the number of units of length that are counted is less than are counted in the rest frame, but the units of length are longer in the moving frame. And so the fact that the units of length are longer cancels out the fact that the number of units counted is less, and it turns out that the length of the ladder is the same in both the rest and the moving frame, and that special relativity is just a bunch of messed up mathematics. Okay.
It seems like you're moving to a conclusion that the Lorentz transformation is basically not needed in physics.
No, I'm not saying that. I'm just saying they're doing the math wrong. Whether you argue for that other conclusion, you have to do that using the correct math. In other words, what I'm saying is that if you're not using the correct math, you don't have the correct mathematics, then you don't really know. You can't really apply. You can't apply incorrect mathematics to physics. That's my point. And what they're doing is they're applying incorrect mathematics to physics and making deductions from that. So whether the Lorentz transformation is correct or not, true or not, you can only decide that if you use the Lorentz transformation correctly. You have to use its mathematics correctly. They're not using its mathematics correctly. That's the point. You have to use the bijective transformation pairs. They're not using the bijective transformation pairs. They're using non-bijective transformations, which means that you have not satisfied the condition of proving that your claim is uniquely true. In other words, the whole point of the bijective transformations is that if you prove one-to-one and onto, okay, that's necessary and sufficient conditions in mathematics, you prove that it's uniquely true. So you have your theorem, okay, you prove the necessary and sufficient conditions, you prove that your transformations are one-to-one and onto. And when you've done that, you've shown that what your result is uniquely true. Okay, in relativity, you don't get uniquely true results. As I pointed, that's the whole point of this ladder paradox that I'm talking about. There's no uniquely trueness about anything about this thought experiment. It's like you don't know what's really true. What the length, you start off with an assumption that says the ladder's too long. But if you don't know whether the ladder is too long or not, and you make a measurement of it when it's moving, okay, according to special relativity, you can't really know what the true length of the ladder is unless you use the bijective transformations, because relativity is all messed up in the math. So,
well, if an observer in one frame already knows the length of the ladder and the size of the barn, why is it necessary to even consider another frame? The first guy in his frame already has the data and information he needed. I mean, what is the expectation that any other information would be gathered by changing the frame?
Well, my point is that this is a thought experiment. It's something that they invented to explain special relativity. Okay. So you as a student are presented with this problem like it's an exercise in a textbook, and you're supposed to puzzle over it as a student, and then the professor explains to you what the correct explanation of it is. It's relativity of simultaneity, and time is not absolute. So you're supposed to conclude from this confusing demonstration that they present you that this proves that time is not absolute according to special relativity, and special relativity is correct. Now, my argument is that's just a lot of malarkey. Time can't, they don't prove that time is not absolute. They just prove that their math is messed up.
Well, Walt Disney, with his original cartoons, Mickey Mouse and so forth, pretty much proved the fact that it's very easy to write these scripts for these cartoons. You don't need to be smart. You don't need to have a great intellect at all. In other words, I think what this shows is that science is difficult and requires some degree of intelligence. And that is Wolf, and I think this agrees with your point, Harry, that in special relativity, in these Lorentz transforms, intelligence and creativity and hard work is really not needed. You can just write any script you want.
All right.
Make your cartoon.
I'm not sure I understood that. The point I'm making is
that science is hard and requires intelligence. These thought problems and so forth are scripts that even Walt Disney showed can be churned out. So there's a different cartoon every Saturday night at the theater.
Well, that's true because it's a defective theory. It's not really based on good mathematics. It's not based on Einstein came along and said, well, we don't need the ether, that's superfluous, and he does a presentation of a Lorentz, calculates the Lorentz transform assuming principle of relativity and constant speed of light, and does this demonstration. It doesn't really make sense. And he says, well, that means that time is relative, because relativity of simultaneity and this and that and all these other, these fudge factors that go into it. And because they thought that Einstein was a really, really, really smart guy, and he was so much smarter than them that he was right and he knew what he was talking about. And they apparently fell into this trap of believing nonsense.
Well, Harry, you're very diplomatic. I would go state a similar thought, perhaps a little more aggressively. I wouldn't say that the kinds of things that you have presented today and previously raise questions about the science of special relativity. I'd say that these things aren't science at all. They're not even science, and I wouldn't even dignify them to saying that we're disproving a scientific theory, because it's not a scientific theory. There's no science there at all. It's all cartoon.
Right. Well, that's one way of putting it. I put it a little differently.
You're more diplomatic.
I'm saying that it can't be science because the math is wrong. The math is wrong.
Okay.
It's not more complicated than that.
There certainly is a question as to whether this would have been accepted in a previous age, where we used more Grecian logic or even, the sort of mathematics and physics of the last few hundred years. It seems to be something very strange, maybe, that started at the beginning of the 20th century. So in other words, if this paradox had been raised maybe 200 years ago, they might have said, well, therefore that theory is incorrect. It just flies in the face of logic. It's not sufficient to say, but here's the relativity of simultaneity. You're not taking that into account. And if you do, it solves it. Now, they're not explaining how the relativity of simultaneity explains everything. It's as you say, it's a red herring or just a catchphrase. So you can take something like this. If this had been put to people maybe 200 years ago, or 150 years ago, you're riding in the cab of an old steam locomotive. Now,
unfortunately, you got interrupted there.
Yeah, if I may come back, thanks very much.
That's an interesting point that you were making. I would think that if Einstein had proposed his theory today, the mathematicians would have just never. He wouldn't have gotten in the front door because we know much more about mathematics. when Einstein did his thing, I don't think they understood transformations, the theory of transformations. They didn't understand bijective, they didn't. I mean, this is all elementary stuff in math books, bijective transformations, necessary and sufficient conditions, one to one and onto, one to one and onto is the way they talk about it today. And you have to prove these things. And I don't see anywhere in special relativity where any of that is proved, any rigorous mathematics is presented. They pretty much rely on the idea that experiment proves it's correct, so therefore it's correct.
So I was postulating that perhaps 200 years ago, or during the golden age of mathematics, maybe the 19th century, this wouldn't have been accepted. And you're perhaps going further. You're saying maybe had it been introduced today, 100 years later, it wouldn't be accepted either. It was maybe a small window of time where, I don't know, fuzzy thinking or whatever it is. It may be political as well. But I was giving a sort of a very specific example, which you may have heard of. You're in a locomotive, and from the point of view of the driver in the cab of the locomotive, the distance between the axles and the wheels is constant because he's not moving relative to it. But the piston is actually moving at a speed relative to the driver in the cab.
Right.
And therefore, that's contracted according to the Lorentz contraction. And therefore, the distance between the axles is greater than the distance that the crank is trying to enforce a momentum to. And the whole system would break up, it would be unstable. Now, that's so obvious a problem that I say that had it been given to, an elementary mechanic, he would say, "Oh, that proves this system is wrong." And it's not sufficient to say, well, the reason you think it's wrong is because you haven't taken account of the relativity of simultaneity. I'd like to see how that explains it.
Yeah, well, I was never able to that's an interesting paradox. If you start researching these paradoxes, there's more of them pop up. I thought I knew all of them, but the more I do work on, the more pop up, and they pop up in strange places where you don't expect them. There's problems in electromagnetism. I even talked about electromagnetism. There's one of the problems in electromagnetism is that the beta factor, the Lorentz factor, increases with velocity, right? And the beta factor multiplies, and so the equation is beta times the electric field plus B cross the magnetic field. Okay, well, I looked at that, and when I first started looking at this would have been 25, 30 years ago. And I thought, that means that the electric field increases to infinity as you get close to the speed of light. How is that possible? Apparently, nobody's ever thought about that as a problem. The electric field increases to infinity. The magnetic field does too, because according to the equations, when the beta factor goes to infinity, and so it multiplies the electric field. So how does the electric field go to infinity? I never could understand that. To me, and all these equations, they all show that. Doesn't make any sense to me. And this is when I sent this off to Mendel Sachs, back, and I said, ask Mendel Sachs about this. He didn't really like to see this. He didn't have an answer. Mendel Sachs is
Who's he?
Mendel Sachs is a physicist who at Syracuse University,
Okay.
who a kind of a well-known, published a number of books on special relativity. He had a blog thing, like an internet thing where you could ask questions. Anyway, that's my fun story. So I didn't even talk about the paradoxes that could arise in special relativity. I mean, in electromagnetism, and they use this length contraction in electromagnetism to explain the existence of the magnetic field. So here's a problem now. If the length contraction isn't real, then their explanation of where magnetism comes from just kind of goes by the board. Okay. So is
But the length contraction is just the obverse side of the time dilation. If you take the orthodox special relativity interpretation, and if one is true, well, then the other is true. But the very fact that there's clock retardation of atomic clocks, I think most of us agree with regard to this, doesn't substantiate time dilation, which I think most of us would think is a fiction. But if they claim that time dilation, it comes out of the equations and it's been established and so on, well then the converse of it, or the obverse of it, is length contraction. And to deny that, I think would
No, you've got it
question the whole
wrong,
theory.
Ian. It has
What?
to be to keep the speed of light constant. You have to have an expansion, because the one in the Lorentz formulas, it's always an expansion in the moving frame. So if you divide time dilation by, or the other way around, length expansion by time dilation, then you get a constant speed of light. And I sort of believe in that concept. But the whole thing's messed up at special relativity, because it's only unreflected on one dimension. So
okay, let me interrupt you. I was going to talk about this later, so you brought up the issue. I've known this for years, that it doesn't make sense. Length contraction doesn't go with time dilation, because what you get, the speed of light is not a constant. They have to be the same. So you have to have length contraction. I mean, if you have time dilation, you have to have length dilation, because when you divide length by time, if they're not, you don't get the speed of light as c. You get it different from c. Now, as I mentioned earlier, this Victor Schatz published a paper about this at ResearchGate. And I saw that and I thought, well, I've known about this for 25 years. This isn't really new. And, that's the same thing that you were talking about. So I was going to talk about
but it's also in the moving frame, if you assume that the clocks are measuring time differently, which is a experimental fact, or most people believe it, then if you're measuring the speed of light in one direction compared to another, the dilation or contraction can only happen in the direction of movement. So if you turn your say measuring a speed of light in one direction, it doesn't make sense, because you're always going to get c to be the same. So in the system as it's transformed leads to complete nonsense.
right.
In the as you view another frame in your mind, it's just complete nonsense.
Okay, as I said, I'll talk about the paper where this guy talks about that, Victor Schatz. He talks about that. I've known about this for a long time. I've talked about this issue for a long time, for 20 years or more, and it's kind of fallen on deaf ears in the dissident community. They don't really quite get it, I guess. But from going back to what you were saying, Ian, you're aware of the fact that they do these proofs where they prove the origin of magnetism using length contraction. You're familiar with this?
Yes. When you said that, Harry, I was thinking of how they're looking at electromagnetism as being sort of relativistic effects.
Right.
Magnetism being
is a
right. Yeah,
right.
so the gamma factor comes in, and the beta factor and all that, yes. But I'd have to give it a little more thought, what you said about these things going off to infinity. I didn't see that coming. I mean, I have some textbooks which ostensibly say they're using relativity to establish the equations of electromagnetism. And then they said if you're not familiar with special relativity, well then you can skip that and just go to the equations which were
Right.
known in classical times.
Well, my point in bringing that up was when I saw that, I couldn't understand it, and that's not my point to talk about that because I had planned to talk about that in a different presentation. But it turns out when you get into the electromagnetic part, the fields part, it just becomes extremely complicated. The field equations become, and most books use four vector notation and all this. It's very hard to really make any sense out of it. So I just kind of avoided that. But the bottom line is that if you believe what the relativists are saying, okay, um, they they claim that you need length contraction to prove the existence of that length contraction, a real length contraction, is necessary to show the existence of the magnetic field. But is length contraction real or not? I mean, Einstein says it depends on the observer. So I don't really know what it is.
I mean, my quick answer to that is length contraction comes out of the Lorentz transformations. We can argue about which form, but it comes out of that. And therefore, they say, well, since the Lorentz transformations are the correct transformations between electric and magnetic fields, in one frame, if you're moving, you get if you're not moving, you get an electric field. If you're moving, you get electric plus magnetic field. But I would claim that the Lorentz transformations are an approximation, if you like, to the reality. They're giving these erroneous results, such as constant speed of light and such as length contraction and time dilation. I say those are erroneous. But if you use the correct equations, you will get you'll get a transformation. You'll get a magnetic field without any length contraction. It'll appear to look a bit like the Lorentz transformations. Because, as I say, the Lorentz transformations are just a mathematical trick, which you're arguing now it has been applied incorrectly, which is quite interesting as well.
All right. Well, okay. Any other comments about this?
I mean, I think the length contraction is basically what you've been saying. There's a mix up between a coordinate transformation and a basis transformation, and the coordinate transformation implies a length expansion, and they have to use a reverse that to give a contraction. By it's not really explained but you have to use one way to set out the formulas and then the other way to get this contract. It's not explained at all how they're doing it and what the rationale for the basis transformation to get the contraction is.
But of course, it was Fitzgerald who first conceived the idea a little before Lorentz that if the distance between two objects, or sorry, two ends of a system moving in a particular direction were contracted, that would explain the null, let's say absolutely null result of the Michelson-Morley experiment, which had just taken place in 1887.
But it doesn't because of
well,
the
you don't need that. You don't need, because first of all, I mean, the most basic thing that one would think of, which I was never taught in college, and even to conceive, is there is a dragging, if you like. There's an entrained ether which is dragged by the Earth. So approximately, you won't get any ether wind effect. It's not absolutely zero, but you'll get a very small amount, and it's not measurable by second order experiments such as the MMX. It is certainly actually measurable by first order experiments such as the Sagnac or the Michelson Gale Pearson experiments. So it was a bit of again, it was a bit of a sort of a quick fix. You know, we'll try to introduce this to explain what we know already. And when all these paradoxes came in, well, I claim that they wouldn't have passed muster 100 years before that. And Harry has raised another thing that probably wouldn't pass muster today with the advanced mathematics on bijective systems and so on. But I don't know. Perhaps there was something in the water around the turn of the 20th century, both intellectually or pseudo intellectually and politically, that made all these paradoxes. It
Well,
was a time, maybe of revolutions, of maybe communism coming in and this sort of
I
thing.
think
And
the idea was that people liked the idea that time is not absolute, and they thought that they thought they were being freed from the bondage of Newtonian thinking. So Einstein freed us from Newtonian physics, the bonds, the absolute time, absolute space. They thought that was intellectually, it, moving forward intellectually rather, getting rid of those Newton. There in the 19th century there was a lot of criticism of Newtonian physics, and and Einstein sort of stepped in when that had sort of reached I think, a critical point. Mach had criticized Newtonian physics, and then of course they said, well, Mach attributed Mach to being a sort of a precursor to Einstein, and Mach didn't really like that idea at all because that wasn't anything that he believed in, and so they sort of, you understand what I'm trying to say here? They kind
yeah,
of
I
brought,
think there must be something in that. And also, I think what was arising at the time uh, is a criticism of an ad hominem, I'd even say, criticism of Newton. Around that time, they were saying that Newton was a rather nasty character. Now, I don't know if there's any evidence for that at all. I think quite the contrary. But they were saying books were coming out saying, "Oh, he took the king's shilling by becoming master of the mint, and he had people hanged for fabricating money and so on, for coining money and so on." Uh, and he was very nasty to Robert Hooke and so on, and against Leibniz and so on. They were trying to put him down for some reason or other. I think he had none of those traits. So you're right. Now there's another point. Some of the sort of more traditional people say at that time they wanted to get rid of, like, say, very fundamentalist religious people would say they wanted to get rid of absolute morality, that you shall not do this because God said it 5,000 years ago. So they want to have relative morality. It's all up to the individual, and that's why it came in. Now, I don't know if that's a factor as well, but there seemed to be a strange mix in the air around 1900 or so, and that possibly would not have held muster at any time previous to that, and maybe, as Harry says, even at a time subsequent to that.
okay, yeah, I think it's like Einstein was the new woke in the modern terminology.
Yes, yes, yes.
Okay, I want to bring up what James was talking about here. This is this is a table that Victor Schatz produces in his paper, and his paper is he claims that Einstein's theory disproves the second postulate of special relativity. So his paper has this controversial title that says, in effect, basically, that Einstein disproves his own theory by negating his second postulate. Okay, and here's the table. I'm not going to go into the whole paper. The English in it is very hard to read. This is at ResearchGate. But you'll notice that he's got the four equations here. He's got delta t prime equals gamma t, delta t, delta t. He's got and he talks about time unit. If you look here on the column on the left, he talks about time unit and time measured. Okay, so time unit, that's the basis transform. Time measured, that's the coordinate transform. So he's got the four transforms here for time. Here they are. Okay, and here they are in these. It says resting frame, moved IF. So he says resting IF. I think that means inertial frame. And then he has moved inertial frame, which I think he means moving. inertial frame. We would say moving, moved. And this is an example of the kind of confusion. I had a hard time making sense out of his paper. But anyway, he has the 4 transforms for time. He has the 4 transforms for unit length. He's got the basis transforms. He's got the length measured, which would be the coordinate transforms. He's got those. Okay, and then down here where he says second postulate speed of light. Okay, and he's got these gray boxes. He shows that if you do the length contraction, you assume length contraction, you get that the velocity of light is not c. Okay, so, and it's a pretty simple, James explained this. In order to get the speed of light constant, you have to have time dilation and length dilation, because when you do the, when you divide length by time, okay, they have to, in order for the beta factors to cancel out, they have to be time times beta, length times beta, and it has to be consistent. Okay, and so in this gray box here, he shows it. So his argument is pretty much what James was saying, which is that length contraction doesn't work. It's length dilation. So time dilation, length dilation. Okay, that would be in the moving frame, the basis transformations in the moving frame. So here's the equation. If it says time unit, delta t prime equals gamma delta t, length unit, delta L prime equals, well, he's got this equation wrong here. It shouldn't be divided by gamma. It should be times gamma. Okay, so apparently he's messed up somewhere along the line here. I'm not sure exactly how he did this, but he shows, I think what he's saying here is that if you assume this would be the relativity transformation, delta L prime divided by delta L gamma. Okay, now if you use that equation, you get the wrong answer in the box down below. I think that's what he's doing here. Oh, and over here, he's using the coordinate transformation in the moved IF boxes. And it's kind of a confusing thing, I have to admit. I can't really.
But not for the mass. The form of the equations for the mass are entirely different.
Well,
I think those are the equations that you said were totally wrong.
Well, let's just, he's got a mass unit equation, and I don't think he did something right here. Okay. It's confusing what he did. I'm just pointing out that he talks about time units and time measured, which is what I'm trying to point out, is that you have to have a basis transform and you have to have a coordinate transform. So the basis transform transforms the time unit or the length unit, and the coordinate transform transforms the time measured on the clock or the length measured on the ruler. Okay. And you have to take into account these different, the time unit and the number of units measured. So you have to consider both transformations. You can't just do one, which is what they do in special relativity, and they get the wrong answer. So this is I thought it was kind of interesting that he is sort of making this argument. And James, I think it's interesting that you brought up the same thing. He's pointing out that if you do length contraction, if you combine length contraction with time dilation, you don't get the speed of light as constant. That's the point. You have to have time dilation and length dilation to get the speed of light as constant. You have to
the gammas don't cancel out. You actually get gamma squared.
Correct. That's it. Correct. You get gamma squared. Well, that's something that I discovered more than 20 years ago. And James seems to have discovered, this guy seems to have, I don't think this guy is that old. I think he's probably 30 or so, because he talks about his university experience. He talks about his friends in the university talking about this. And that's how he came up with this time unit, time measured stuff. Okay. And it's not, he's sort of got the same idea that I have presented in the last and talked about in my papers at the General Science Journal, this idea of the transformation of the basis or time unit and the transformation of the coordinates or the measured values. Okay, so he's got time unit, time measured, length unit, length. So he's combining them together. Okay, rather than what they do in special relativity, which is they assume the time unit and the length unit don't change, which doesn't really make sense because then they turn around anyway. That's just more of the confusion. So any questions about this?
You haven't mentioned my point that in the Lorentz transformations, you're only changing one dimension, one of the three dimensions. So in time, it doesn't matter what orientation a clock is put in, you get the same time or whatever the frame is moving still, whatever. And yet there's dimensions which are changing relative to each other and have to be somehow hidden. I object to that as well. It's just it's something that has to be there apparently, but when as soon as you try and think about it and how you discover it in reality, it doesn't exist. So what's the point of having it? So I'm trying to create the system where all the three dimensions change in exactly the same ratio. So they do actually contract. All three dimensions contract, and the maths works out there as well.
Unfortunately, they dilate.
No, in this theory they dilate, but if you do the maths where they contract all three of them, you can create a as I showed in one of my talks, that you can create a set of transformations which do actually work.
Well, I think the bottom line is that the Einstein theory doesn't work. That's the problem.
Yeah, we agreed on that.
And so they need to work out. They need to solve the problem. Unfortunately, they're blocked in making progress by the fact that they've accepted the ideas of absolute time is incorrect and absolute space is incorrect, and so they've dug in their heels on these conclusions of being anti-Newtonian, and Newton is wrong. They've also rejected Lorentz, and it turns out that their attempts to get a consistent mathematical physics out of this Einstein postulates doesn't really work, and that's really the point. Mathematically, you can fudge the math around, which is what they do. They fudge it in the paradoxes. I don't know why they present paradoxes. It's kind of their attempt to sort of make the point that special relativity, it doesn't have absolute time or space. And so we can accept results that are paradoxical because that demonstrates that time and space aren't absolute and that our theory is correct. That's kind of their way they try to argue the case. And I don't really see that type of reasoning to be valid.
But getting back to the sociological question as to how this came to be adopted, I think I'm seeing some holes in the whole acceptance of this. Maybe it's wishful thinking, but I think had we been speaking 50 years ago, there would have been short shrift for us. There's not much acceptance of the possibility of the received views being incorrect, but there are some possibilities. For example, Roger Anderson's going into all this AI and business and chat GPT and so on. I mean, it's very ponderous, but he's getting out of it. Oh yes, maybe there's some problems and illogicalities in that, and you could look at it in a different metaphysical way, and maybe, it does seem to be absolutely saying this is gospel truth, and you have no right to dispute it under any circumstances. It's the relativity simultaneity will explain everything. So I think things are beginning to gain a
But
little
AI
degree
is
of
for being
analysis.
not dogmatic, and it be equivocating on any subject. I don't think it's designed to create strident opinions. AI.
That's true. That's true, James. But I suppose what I was thinking of was that the AI, which I have no time for, basically, is just an assembly of the opinions out there on the web. So you would expect it just to be mirroring the mainstream views and the views that are expressed most vociferously and in greater quantity would be shown on the AI. So I was a little surprised to see that maybe Roger was getting it to accede to some of the points he was pushing it, some of the directions in which he was pushing it. So I take your point, but that's the conclusion I came to, provisionally at least.
Well, the basic objective of the AI is to have you continue to pay the subscription fees, and also to gather data about you, not you, EEM, but you, the general you, for their database in order to craft ads to sell you stuff.
And that's very true, of course. And of course, the Chat GPT, which Roger favored, I saw that it's formulated in a very user-friendly way. It'll make sure that it's not insulting you in any way. If you put in the most ridiculous thing, it'll say, "Oh yeah, very good point that you've raised this. You're to be congratulated." And it's all sort of praising the person putting in the answer. So I'm sure there's a commercial basis to all that.
Oh, sure. They want you to continue paying them money.
Right.
Well, unfortunately,
the customer is always right.
Yeah.
well, I don't really have any.
Tell a few words.
Go ahead.
Harry, can I? Okay. Thank you so much. I'm absolutely agree with Jim, who told that we are talking about cartoon, but not a real science. Unfortunately, Einstein freed us not only from Newtonian physics, he freed us from classical physics and put us into the mass of mathematics. This is what happened 100 years ago. I don't understand how the people, great scientists, great mathematicians 100 years ago, who could accept these bullshits from mathematics, from physics, from all the points. And still we are talking about this cartoon instead of forget about it. It's absolutely wrong. Absolutely wrong. As I told you many times, guys, Newtonian was absolutely right. We have absolute frame of space. It's a cosmic medium. And we have absolute time. That's why all these talks about the special relativity, general relativity, all these mathematical tricks, it's wasted time. And unfortunately, it's far away from physics. Theoreticians, they thought that they're thinking that mathematics will explain everything. On the contrary, it's not explaining at all. Harry, you gave so good presentation right now about the bullshits of this special relativity. I don't know why we need to waste our time, one more time to talk about this tricks, dilation, attraction, and all this stuff. Forget it. There is no vacuum. No, there is no vacuum. There is no speed of light. Many times I ask you, guys, there is no speed of light. There is no such definition even. In Maxwell equations, there is electrodynamic constant. Speed of electromagnetic waves, it is different. Experimentally already observed and confirmed by fast radio bursts. Why we are talking about all this stuff? It's obsolete. We must forget about it. We must. I don't know. 100 years ago, Hilbert, he was very close to the same general relativity equation. He was a great mathematician. How he could accept these bullshits of Einstein? I don't understand it. I don't
Well,
understand what's happened to the people, to the great scientists 100 years ago. Why they followed this absolutely wrong cartoon? It's not even physics. I'm very
right.
sorry, guys, for my emotions, but it's
Okay,
time to
well,
stop already talking about this. Jane, thank you so much for very good definition of special relativity. I do like cartoon. Thank you very much.
okay, well, to answer your question, why we're talking about this. Okay, I've been talking about this for 20 years, 25 years. I have papers at the GSJ. Um, nobody's paying attention, nobody's concerned. So I'm just getting it off my chest. Okay, I'm explaining to other people, maybe by the fact that it's on YouTube and it's recorded in video. My position is well established, and my arguments are put out there for other people to see, that other people could reference to and refer to. So that's the purpose of the presentation today. And the summary of it is basically the paradoxes that we're talking about, that they're basically thought experiments that try to demonstrate false ideas. Okay, relativity of simultaneity based on the idea that time is not absolute, and the other idea is that space is not absolute. It's really just a lot of messed up mathematics. It's not based on correct mathematics. It's not based on mathematics that's uniquely true, that you can prove is true by doing the correct mathematical procedures, using bijective transformations, one-to-one and onto, necessary and sufficient. It doesn't follow the correct mathematical procedures. It uses the wrong evaluation conditions, and in using the incorrect or wrong evaluation conditions, it gets contradictory answers, and those answers are said to be validated by the relativity of simultaneity. So because time is not absolute, therefore, paradoxical results in physics can be accepted because time isn't absolute. Space isn't absolute either. We've completely negated Newtonian physics to the point where we're not even using correct mathematics anymore.
Or we've negated science.
But each individual model has to have one definition of time, one definition of length. So you have to use one frame as the master frame and relate all the other measurements to that. You can't. It doesn't make sense to have multiple. In general relativity, you have multiple different measurement frames effectively, because the speed of light is constant, but all the measurement definitions of length and time are different in every point of space from here to the sun and back again. So
yeah, it's kind of confusing.
Yeah, you've only got one standards office. Keep the one standards office and try and relate the whole world model to that standards office. That's what we should be aiming for. That's the summary I'd like to.
Yeah, but his theory is that every frame has a different time and space, and so therefore, and they've accepted that idea, and that idea just leads to confusion. That's basically the bottom line. We got rid of Newton's absolute space and time, and got Einstein's crazy space and time, and now we're trapped in trying to make sense out of it, out of physics.
But I'm still trying to fathom why sociologically, if some of these problems seem so evident to us, we have millions and millions of people, I suppose, all over the world, some of the most educated people,